Good evening, good afternoon, everyone. So, as some of our department present about how they do from the application side of things, like Peng and Mari, and this morning Fabian Thais. So, my talk will be based on as a IT infrastructure, what we do and what we offer for our users. So, around about 10 to 15 minutes. So, I try to give a picture on a really high level, what is there for our researcher to do this kind of computing. So as you can see in the picture, so these are, as you can see, these two arrows. So those two arrows are the data center location where our computing infrastructure are hosted. And this one is right below this building. Oh, so yeah, I think you see there's an octagon building, and next to that, okay, I can maybe this one. Yeah, yeah. This is that's the building we are at the moment. Yeah, right. So that's the building where we are located at the moment. Yeah. So my agenda.
Anyone wants to have a tour of this? It's 1 room, 10 ranks.
Yeah.
Let me know.
Yeah. So happy to do that if somebody is interested. So so this will be the brief agenda for my short talk. So I will not gonna dive into that right now. So as the topic comes along, I will talk about it. So our cluster is based on typical Slurm-based cluster. So I don't need to explain what is Slurm to everybody. Just for yeah, so I'm going to talk about the resource what we have. So as you can see, we have 18,000 plus logical code for people to play around and whatnot. And then we are basically at the moment x86 based center. So we are in future considering ARM based and RISC-V RISC-V processor, but not yet. But yeah, at the moment, Intel and AMD is talking about accelerators. So we have 130 plus GPUs at the moment, all based on NVIDIA. So V100, A100, all the goodies with that. Storage. So we are. So our partner is DDN, and then it's based on Lustre file system. I will talk more about that in the coming slide. And then for network fabric, we have, as a typical any HPC center can have like in IB fabric, SDR100, and then in the Ethernet fabric, we are newly implementing this Cisco ACI fabric, so SDN based. So it's really really good at the moment for QoS, load balance, whatnot. So for better network segmentation. And this is like the typical memory per compute node in the cluster. On the software side of thing, this is again on a very base level. So I'm not gonna deep dive into the application side of things. So we have Rocky Linux since CentOS is dead. So we picked Rocky Linux for our cluster. Yeah. So maybe it's get boring if I talk more than what is already written here. Yeah. So container, we are Aptainer or Singularity, Charlie Cloud. So yeah, so this will be from the software side of thing, and for I don't know, for maybe IT admin could be more interested about this, how we monitor provisions things in the cluster. So we have Foreman, Ansible, CheckMK, Grafana, DDN Inside, Robinhood, and S-Trigger for the IT admins. Yeah, so I will also want to talk about how we come up in this last 2 years, the idea behind having a big centralized cluster. because before this, there were like some PI get some money and they will have their own mini cluster, let's say, and then the scientist has to learn a system administration skill and then try to, I don't know, set things up. So we try to help our researcher to focus on a science, and we take care of the IT and technological stuff. So this is one of the idea behind this. As you can see, the silos and shadow IT, we are trying to reduce with that because we have a centralized HPC expert now with this. Easier billing, so it's much more better for doing that. Yeah, as I mentioned, the HPC expertise has been shared. So yeah, it's again like money can be, I think much more better invested because we have a lot of money, as compared to some PI gets a small grant, so it can be like segregated and you can go for a big investment like what we have at DDN and all the NVIDIA's investment. So yeah, I try to summarize because of this centralized concept. Now we have this possibility to buy a big machine like NVIDIA HGX, DGX machine in the HPC infrastructure. More and more capable CPUs, whatnot. And then Cisco ACI was one of the investment of because of this. And yeah, DDN. So before this, like we were on a file system level, we have NAS based, yeah, and then it was not so like compared to parallel file system. So the DDN infrastructure, what we have for our users, so it's based on EXAScaler 5.2.4, but we are considering 6 in coming months. And yeah, so around about 18 petabytes of spinning disk, around about 40 OST, and then half a petabyte the SSD pool for really IO based. Yeah, again, so this is a summarization of yeah, I don't want to bore you with this, but yeah, this is the DDN component of what we have, and then yeah. Yeah, so now, as I mentioned, we had a NAS-based NFS storage before, and then I just wanted to highlight how DDN and Lustre has improved the throughput and I/O significantly for us and our research. So, as you can see, there was a small benchmark done on this. So, as you can see, this. There's a storage, Lustre, and then local scratch. So local scratch was purely SSD based, but we are not able to reach that. I mean, it's really hard to do reach that level. But yeah, as you can see, the performance gain from switching from typical NAS based storage to parallel based file system. And yeah, this slide talks more about. Yeah, so this is how it's been set up on a HA group. So we have a lot of VMs, OSS VMs. There's proprietary DDN SFA OS in it. And then this is the HA stack for our storage. So basically just wanted to highlight how resilient it is for our researchers. Yeah, and DDN and NVIDIA is like bread and butter for us. So as I mentioned, like we have Mellanox-based switch, we have NVIDIA DGX boxes, and we have, so yeah, it's like a really essential component for us. Like without this, I'm not sure if we can do that much high throughput computing and whatnot. So just wanted to put this in this. And I just picked up the 10 most used application in the cluster at let's say for last 1 year or so. So these are the list. As you can see, we have wide varieties of application on the cluster. So I will also get in touch and talk about some of the current limitation, and as I imagine most of the HPC center has a similar limitation. Yeah, since the users are ever growing and with their ever growing demand and application, so yeah, it's a challenge for a small team to train them, support them, and do all the heavy lifting, patch it, whatnot, right? So yeah, so this is one of the current limitation at the moment what we have. GPU is always highly requested. Everybody fancy to do GPUs, and yeah, it's highly requested and are limited. As NVIDIA CEO says, the more you buy, I don't know, maybe we have to follow that ideology maybe. Not enough power and cooling, so I imagine it's the same problem for most of the HPC center. But yeah, just wanted to highlight what we have current limitation. So this could be my second last slide or last slide maybe. So I want to talk about the upcoming project. So we want to do a POC on GPU Direct on NVIDIA GPUs going forward. Since the GPUs are limited, so we wanted to do this GPU slicing concept and integrate it with the SLOM, so that we can accommodate more jobs per GPU. So that is the idea behind this. Yeah, so we also wanted to continue our testing with the DDN all-flash storage for AI-based workloads. So we will be collaborating with our AI users. Object-based 3 is under consideration for us. And as I mentioned before, we want to do an upgrade for 6.x and all the goodies it comes with that. Yeah, and obviously we want to buy more NVIDIA newer Hopper-based GPUs and do some POC work on that. With that, I think this was my presentation. I hope it was not too boring, but yeah, I just wanted to highlight on a very high level, like what we provide to our research center. Thank you.
Thank you very much. I had one question. One of the things you actually got on the list is you're looking to buy some of the H100 systems with NVIDIA. You had also your list of your top applications. Have you done maybe some work with NVIDIA about working at which of those are really driving the need for H100? Which ones are going to make the most difference?
Yeah, I think the machine learning is one of the high driver for, I think, going for that new architecture. So yeah, and I think we have already been asked by our users to buy and test this. So yeah, this was one of the reasons behind this.
Okay. Yeah. Okay. So there's quite a lot of awareness within your users and community of what they need. Is that, I guess, is that in partnership with Marie's team and with
team? And a lot of Fabian users. So we have a lot of, and because of the cooling limitation, as Fabian was mentioning, we could not buy more of those GPUs. But yeah, I think. Yes, I think, yeah, we have the money, but because of that, we...
It's really good. I like to talk about GPU, but now, did you hear about DGX Cloud? So
right, yeah.
It's basically the same machine as you have, as you show on the picture, but we rent them. So in a way, you have problem of cooling, power, and everything. If you have large workload, you can get access to the exact same machine with the same install, everything in basically your rental model. Yeah. And it's DDN also, in fact, storage is everything the same. And you see them. So we have an interface that allows you to see your local machine, and you basically also manage the other machine, which are your machine for the time of your rental. So you can burst into an extremely similar environment. So you don't need to like go switch, okay, it's a new system, what am I doing? No, it's exactly the same.
Yeah.
Really hard to do from a kind of management standpoint. And we don't have these large models where we say, okay, we have this model, we need to train this, and it will take this many petaflops or whatever. These are much smaller systems, and then we are not running millions and millions of pictures through it for inference. It's maybe like 100 or 1,000, and then we are done. And so, I'm sorry, I'm not using the microphone.
Maybe to finish.
Yeah, sorry for the online people. So our workload is really much more small scale and diverse, and therefore it makes this a little harder to do. But we have an eye on this, and cloud bursting is definitely something.
You could keep potentially the one.
Yeah. So we are basically looking at all the options because like we want the research to continue on. So for sure, yeah.
And do you typically run many single node workloads, like 1 million jobs on the scheduler does all the work, or do you have also some jobs that span multiple nodes, so like maybe the full system even?
Yeah, I think in our research center, most of the time it is either 2 GPUs or maybe 4 or 8. So we don't have that many users doing like, let's say, I don't know, parallel, 10 GPUs node at the moment. But yeah, we have some use cases, but not so much.
I think I recognize your description of diverse, badly formed workloads that are all very small. I do have some concerns. Sorry, I know NVIDIA are a lovely company, but they make lots of money, so they can listen to it. Their pipelines are set up for these really big jobs and to make it work. And there's nothing more depressing than to wire up GPU nodes and watch them not draw the power that they're capable of doing because they're allocated, but they're not doing work. We're trying to look for alternatives around it. One particular one, because we're being pushed to build a Kubernetes type cluster for orchestration, is an orchestration platform for which there's something called Run AI. It doesn't have to run AI, it's a CUDA orchestrator. So it also, they say on the paper, it targets people doing interactive work on GPUs, and if you leave them idle, it takes that off the GPU and puts other work on it. I don't know whether it's going to work, but I think that's definitely going to be on our list to see whether that can make. I'm not very happy with their licensing model either, but we'll see how it goes. But getting that usage up, I think it'd make a real difference to the problems of power and cooling in a data center if the GPUs could be run flat out for the diverse workloads. It makes a big problem for us.
Yeah, I mean, we see that. I mean, that's why we're looking into the GPU slicing, because we see, I mean, not big jobs that use multiple GPUs and really use them, but we see single jobs occupying a whole GPU, but not really utilizing all the cores there. And so that's why the GPU slicing. And as an experiment, I would be really interested in porting some of the code to kind of Intel optimized PyTorch, because that's a lot of the stuff. And then just compare this, running it on a CPU versus on GPU. Are we losing really that much by doing that? And that would save so much power, right? But of course, no one has time to actually do such an experiment.
So I'm not from Intel, but being that there are Sapphire Rapids now with these advanced matrix engines, is that an option for Helmholtz?
Just need to convince the researchers that it's hip to do AI stuff not on GPUs. I think that's the only
Because it's much
reason
easier
why
to
they're
share
not,
core.
not trying it. I think, yes, absolutely, we should try that.
It's much easier to share core than having to share GPU between many users.
Looks like we reserved all the questions for the last session. You mentioned something about the future projects and object storage being interesting for you. Do you see some applications that are requesting this or requiring this, or is just prototyping to see what could be built?
It's just prototype, and we want to explore for Slum cloud busting. We wanted to explore this, and then for our other use cases. So it's at the moment just a prototype, let's say.
Okay, understood. Thank you.
Lots of good questions there. Well done.
Yeah,
Thank
thank you.
Thank you very much.